Okay, so good evening, everyone. So welcome to the problem solving and drought clarification session for the NPTEL online course on the topic water and wastewater treatment. We are in week 4, and as you all know, this course is being taken by Dr. Bhanu Prakash from IIT Roorkee, and I am one of the teaching assistant for this course, and I am a PMRF scholar at the Department of Civil Engineering at IIT Madras, where I am pursuing my PhD in environmental engineering. So that's a brief introduction about me. So we'll quickly see the contents that were discussed in week 4 lectures. So we started with primary settling tank. We saw all the factors, parameters related to it, and then the design aspect of it. And then we moved on to the biological treatment, where we learnt about the basically the BOD and nutrient removal and focusing on the activated search process. So we saw all the material balances and the mass balances in the with respect to the activated sludge process. And at last, there were a few sessions on the oxygen transfer, like how it changes with elevation and temperature and all, and the basic principles related to it. So this was the brief content about this week's lecture. So I have some questions, both multiple choice questions and some subjective type. We will solve them one by one. Okay. So we'll start with the first question. Okay. So the first question says that grit and sand particles are usually removed from wastewater by which type of settling? So it is asking the type of settling for grit and sand particles. So is it flocculent, discrete particle, hindered, or compression settling? So please let me know the correct answer. Like which type of settling is governed when we try to remove the grit or sand particles from our system? B,
Discrete particle setting.
discrete particle settling. Anyone else? Others, give it a try. Please type in your answer in the chat box or you can unmute yourself and speak.
Discrete set particle settling.
Discrete particles. So most of you are saying it as discrete particle settling. Okay, can someone tell me like which law governs the discrete particle settling or which law do we use while designing for discrete particle settling?
Stokes law.
Stokes law. Yes, exactly. It is the Stokes law. So the answer is correct for this because any kind of suspended inorganic particles are generally being taken into consideration as the discrete particle settling. So B is the correct answer. So any sand or grit particles follows the same, and it happens mostly in the case of suspension of low solids. Okay, when there will be very high number of solids, then we cannot assume it as discrete particle settling. And in this type of settling, there is no interaction with the neighboring particles. So can someone tell me an example of flocculent type of settling? Like where in our wastewater treatment do we see flocculent type of settling?
Uh, in activity sludge process.
In activated stress process, yes, because the particle tend to form agglomerates and then settle. So it happens basically in the sedimentation tank after the aeration tank during the activated stress process. So in our secondary sedimentation tank, we can see the flocculent type of it. So these are very easy, and we have like the professor has discussed in detail. So we'll move on to the next question. Okay.
What do you mean by low solids?
Low solids, I'm talking about the concentration. So if there is low solids concentration, then only we can see discrete particle settling. If there is high concentration of these solids, then the particles will tend to interact with each other, which you don't want in discrete solid settling. So then it can be a hindered settling or it can go into compression settling also when there is high concentration of the solids. Okay, so discrete settling is only possible when there is low solids concentration in our system. Okay, so I don't have the graph right now. There is one graph which relates to the type of settling and the amount of and the concentration of solids. So there we can easily see like how my concentration of solids will govern which type of settling will happen. Okay, maybe I can show it to the next class or I can send it to you by mail. Okay. I have your email ID. I will send it to you if required. Okay, so we'll come to the next question. So it says that find the terminal velocity of a spherical particle of diameter 0.25 mm settling through water. So we have some data given like the specific gravity, G value, the viscosity and density. So we have to find the settling velocity in millimeter per second. So this is actually a kind of subjective problem because we have to do more trials to get the value. So can someone tell me the approach, like how do we go about solving this equation, solving this problem? Any approach or any law or any equation that comes to your mind by seeing this question? Because it is asking about the terminal velocity of this particle. So which law we can expect to happen to govern the system, or how we can go about solving this problem? Any idea? I will solve it right now, but I just want.
Is terminal velocity same as settling velocity?
So,
Terminal velocity, like it depends. If the it yeah, we can say like the settling velocity, we can say it is the terminal velocity. Okay,
56 mm per second.
56 mm per second. Okay, yes. But like, how did you solve this? Like, what approach did you take? Which formula? Can you tell me? Which formula have you used? Just tell me that. So I think we got this through the Stokes law. By using the Stokes law, whatever equation we get. But be careful. This is only possible if the system is in laminar flow. Okay, Stokes law is only applicable if the system is in laminar condition. So we have to make some more checks, but your approach is correct. Okay, so we'll see how to solve this problem. I will solve this in my iPad. Okay, I hope you can see the notepad. So we will start with, this is the second question. So we will considering Stokes law is applicable for laminar condition. So I'm assuming that the system is in laminar condition. I don't know, I have to check. So the particle velocity or the settling velocity will be equal to rho g into g minus 1 d square by 18 mu. So this is the standard equation. So we will just, what are the values? So rho is 1000 into 9.81 into g value will be 2.65 minus 1 into d square. What was my d? 0.25 into 10 raised to power minus 3 because it was given in mm ka whole square divided by 18 into what was my mu value, 10 raised to minus 3. So if we put all these value, we will get 0.0562 meter per second, or as Saket has also found out, we can write it as 56.203 millimeter per second. But this is the settling velocity if the condition is laminar. So we need to check if my flow condition is laminar or not. So how do we check the laminar or turbulent condition? We will find the Reynolds number. So check for Reynolds number. So can someone tell me what is the Reynolds number if the flow condition is laminar? What would be my Reynolds number? Yes, Saket?
Less than 1.
Less than 1. So I have to find like what is my Reynolds number, and if it is less than 1, then it will satisfy my condition and my answer will be correct. Okay, so my Reynolds number NR will be equal to rho Vp into dp, diameter of particle, by mu. Okay, so it will be 10 raised to 3 into Vp was 0.0562. Okay, into my dp will be 0.25 into 10 raised to power minus 3 divided by 10 raised to minus 3. So this will be my NR, and this will turn out to be 14.05. So it is greater than 1. That means flow is transitional. So it is not laminar. That means our assumption is incorrect. And the answer is also not right. So we have to make some changes in our solution. So what we will do, so I will just quickly give you, like, if this is my flow condition, if it is laminar, if it is transitional, or it can be turbulent. So for, and I will write the Reynolds number, it should be less than 1. Okay. For turbulent, it should be greater than 10 to the power 4, and for transition, 1 to 10 to the power 4. Like more than 1 and less than 10 to the power 4. Okay. And one more term that we need to find out is the, what we have to find out? The CD value. Okay. So this depends on my laminar, transitional, or turbulent value, because this coefficient of drag has to be found out for each condition. So for laminar, it is 24 divided by my Reynolds number. For turbulent, it is taken at 0.4, and for my transitional flow, it is taken as 24 by Reynolds number plus 3 by root over Reynolds number plus 0.34. So please make a note of this table. This will be required for you to solve the problem based on the scenarios. Okay, so this is the table. So now with help of this table, we will solve this problem. So we have found out that my flow condition is transitional. So now, since now we will considering transitional flow. So now to find out my settling velocity, Stokes law will not be valid. So we cannot use that equation 18, that g rho g g minus 1 d square by 18 mu. That equation is not valid. So we will use the standard equation for the settling velocity, and then we will find out which is applicable for our order frequency. So here our Vp was, for starting we will find 0.056 meter per second, and our Reynolds number was 14.05. So now we will calculate the CD value. Okay, CD value. CD value, again it will be 24 by NR because of translational flow, plus 3 by root NR plus 0.34. So if we put 14.05 in this equation, we will get the CD value as 2.85. Okay. So let's say this is my trial one. This is my trial one. Because by hit and trial method only, we will be able to find out the answer. So this is my trial one. Now with this CD value which we have got 2.85, we will put into the standard equation for settling velocity, and then we will calculate the settling velocity. So what is my standard equation of my settling velocity? It is Vp square is equal to 4 by 3 GD G minus 1 by CD. So this equation is applicable for any kind of flow. Okay, for any kind of flow, this equation is applicable. But if this is true, then why we didn't put it in the first place? Why we used Stokes law in the first situation? We could have directly gone with that equation. Can someone tell me why we didn't use this equation at first? Why we considered that it to be a laminar condition? Is there any particular reason behind it?
To find out the CD value.
Yes, because at first we don't know the CD value. The coefficient of drag wasn't known. But whereas in the Stokes law, this coefficient of drag term is not there at all. So we consider it to be a laminar condition and then solve the problem. But now, since we know that the flow condition is transitional, we have calculated the CD value and then we are going to put in this value. Okay, so I will go on. So my Vp square will be equal to 4 by 3, 9.81. D is 0.25 into 10 to the power minus 3. G is 2.65 minus 1 divided by my CD value is 2.85. Okay, so my Vp value will be root over of total whatever is there in the top side. So root over of this. So my Vp value will turn out to be 0.0436 meter per second. So now this is not equal to what I have considered. This was my trial. Okay, I thought my Vp value will be this, but I am getting different. This is not equal to 0.056 meter per second. So that means we have not yet attained our settling velocity. So now we have to repeat these steps again. We have to repeat this again. We have to take now trial 2, where my Vp value will be equal to 0.0436 meter per second. My NR I have to calculate again. I will calculate my NR again. I will calculate my CD again, and then I will calculate my Vp again. So if this Vp matches with whatever I have taken in my
Screen is
trial.
not visible.
Hello, what is not visible?
Screen is not visible.
Screen is not visible.
Screen is not visible.
Others, are you not able to see the screen? Anyone else? I think the screen is fine right now. Is it visible now?
I don't see.
Can you just go out of this meeting and join back again? I think that will help.
Right,
I will
right.
wait
I
for
do.
1 minute. No problem. So we will wait. So I hope you all are able to understand that in my trial 1, okay, in my trial 1, I took Vp value as 0.056 meter per second, and then I solved the whole trial 1. Is it the screen visible to you right now?
Yes, yes, yes. Yes, I
Okay.
can see.
So as I was saying that for trial 1, we took Vp value as 0.056. We know the Reynolds number also. We know the Reynolds number. We've calculated the CD value. Okay. And then we found out the Vp again. Now we saw that that Vp value is not matching to our trial value. That means we have to go for one more trial. Okay, so now we are in trial 2. So in trial 2, my Vp value will be my latest Vp value, that is 0.0436. We will calculate the NR, we will calculate the CD, and then with the help of that equation 4 by 3 GD G minus 1 by, what is that? By CD, I will put and I will again calculate the Vp. So this Vp value should be equal to my trial value. So like this, we have to go on for some 3-4 trials maybe to achieve the final answer. Okay, so please try to do it in your home and come up with the answer. I will tell you the answer. The final answer would be, okay, I think I have it in my PPT. So I think it is around 37, no, 0.037. So whatever be the case, go for some more trials. Your your the, the value which you are taken in your trial and the value you are getting from the generalized equation should match. So once it
Sir,
is matching, yeah,
the second attempt, Reynolds number is 10.9.
yes, 10.9 means again it is transitional. Okay, so
Yes, sir.
again, it will be transitional. So my CD value will be according to my table. As I have given you this table. So again in transitional, what CD value equation you have to take? Take the same equation, then calculate the VP again. Okay, like that 2-3 trials you have to do. Okay. So in
Yes,
this
sir.
you will be able to find out the answer. So I will give you the correct answer. The correct answer is 37 centimeter per second. Okay, 37 centimeter per second is my correct answer. So anything between 35 to 39, if you are getting, that means that is the correct answer. I hope this is clear. If anyone is having any doubt, please let me know. If you want me to explain it again, please let me know. Is it clear?
Okay, sir.
Others, can I get some reaction from you too, if it is clear or not? If you have any query, please let me know, because this is a very important concept. Find out the terminal velocity. You
Please
can
repeat once.
repeat.
Can you
Okay.
please repeat once?
Okay, I will repeat it once. Okay. So, I hope you are able to see my screen. So here we will start considering that it's in laminar condition. Why we are doing that? Because the equation which we have in laminar condition does not consider any coefficient of drag or CT value. Okay, because we in the question we have a set of data. There the CD value will generally will not be given. It is not like it is difficult to calculate as such. Okay, so experimentally it is difficult to calculate. So we will in the question we won't be getting the CD value. So we will consider that it is following the Stokes law, and for laminar condition. And for laminar condition, we have this equation. We will find out the settling velocity according to the Stokes law and laminar equation. So we got it as 56.203. Okay. Now we will check if our assumption was correct or not. Okay. So how we can check the assumption? We will find out the Reynolds number. We will we will find out this Reynolds number. Okay. So what is my Reynolds number? It is nothing but rho Vd by mu. Rho Vd by mu. So we will put all these equations, all the values. So we got 14 as the Reynolds number. Now we know that if my system is in laminar flow, the Reynolds number should be less than 1. But I am getting 14. That means the system is not in a laminar condition. It is in transitional condition. It is in transitional condition. So I have this table. So I have this table for you, which says that for laminar condition, Reynolds number should be less than 1. For transitional condition, Reynolds number between 1 to 10 to the power 4, okay, 10,000. And for terminal condition, it should be greater than 10 to the power 4. And for each scenario, we now have a equation for my CD value. Okay, so now whatever VP value we have got last time, we will take for trial 1, and we also know the Reynolds number which we have calculated, that is 14.05. Okay, so now we will be able to calculate this CD value. We will be able to calculate.
Sir,
Yes,
sir, 0.0395 meter per second.
0.0395 meter per second. I think, yeah, I think
Meter per
that much is enough. 0.3, or maybe you can just go for one more iteration, you will get 0.037, which is the correct answer. Okay,
second. Okay, sir.
okay. So as I was telling, so we have found the coefficient, we will be able to find the coefficient of drag now. So now it is 2.85. We have calculated based on our transitional flow equation. So now this equation which we have is a generalized equation. This is applicable for all flow conditions, irrespective of whatever flow you have, this is applicable. So this is our main equation. This is our main equation. Okay. So in this equation, we will put all the parameters, and we will calculate the VP. So this should be my VP as per the trial. This should be my VP. So we calculated it to be 0.043, which is not equal to my trial value, which is not equal to my trial value. That means I have to go for another trial. That means I have not yet attained my terminal velocity. So with this new value of VP, we will go for one more trial. We will go for one more trial. So now my VP will be, oh, I think, ah, So with this new VP value, I will go for one more trial. I will calculate the Reynolds number first, then the CD value, and then again I will apply the general equation. I will again apply the general equation and then find out what will be my VP value. This is the velocity of particle or terminal velocity. Now this should match my trial value. This should match my trial value. If though the values are matching, that means I have attained my terminal velocity. It is the correct answer. If not, we have to go for another trial. Okay, so it's a bit complex. Complex in the sense is we have to go for some more trials till we attain my settling velocity as per my trial. Is it clear now?
Yes, okay, thank you.
Okay. Okay, so we will go to the next problem now. Okay, so now again, it is about the efficiency of a flow sedimentation tank. So it says that a water sample has a particle distribution as shown. So we have a water sample which has two types of particles. So the size of first particle is 0.3 and the size of second particle is 0.4. Now, out of my 100% of sample, 40% is zero point 0.3 particles, 60% is zero point 0.4 particles, and we have their settling velocity also 0.25 mm per second, 0.3 mm per second. Okay, so this is the information given about my sample. Now, the total solids which is present, like the total number of all particles together, is around 500 grams. Okay, so now the design overflow rate is given, it is 0.3 mm per second. We have to find out, like, if my design overflow rate is 0.3 mm per second, how many particles will get settled, or what is my removal efficiency of the horizontal flow sedimentation tank. Okay, so this is the question. So I will explain the question once again. I will just draw it. Question number 3. Suppose this is a tank. Okay, here two types of particles are coming. One particle, two particles. Okay, one is this. There are two types of particle. I'm just drawing one sample of it. This is 0.3 mm. This is 0.4 mm. Okay, the settling velocity of this is 0.25 mm per second. The settling velocity of this is 0.3 mm per second. This is, I think this is the okay, okay. And out of the total mass, this correspond to 40%. Am I right? Huh. This correspond to 40% and this type of particle corresponds to 60%. And the total mass is 500 grams. So that means 40% of 500 grams, how much? 200 grams is first particle and 300 grams is the second particle, the volume or the mass of the particles. And the surface overflow rate is equal to 0.3 mm per second. It is also given. Surface overflow rate. So what is my efficiency? Okay. So can someone tell me the approach to solve this problem? How we can solve this problem? It's not a calculative type. With like normal calculations you can do. Nothing much to worry about here.
Sir, I think SOR upon settling velocity into 100 is equal to efficiency.
Yes, SOR by settling velocity or settling velocity by SOR. Is it SOR by settling velocity or settling velocity by SOR? Okay, but
Settling.
you are thinking in the right direction. That so we can say that if a particle settling velocity is equal to the SOR, okay, that means it will remove 100%, right? I can say that if my settling
Yes,
velocity
sir.
of a
Yes, sir.
particle is equal to the surface overflow rate or the overflow rate, that means that particle will be removed 100% from the system. So this is the first point to be noted. So that means all the particles of zero point 0.4 size will be removed from the system because my design overflow rate and the settling velocity of that size particle is same. Okay. So all my particles of zero point 0.4 size, zero point 0.4 mm size particles will be removed. So as they are 60%, so I told the total 300 grams of zero point 0.4 size particles are present. So all 300 grams of zero point 0.4 size particle will be removed from the system, will be settled. Is it clear to all of you? Can you please respond? Like, is it clear?
Yes, it's clear.
Okay. So that means that now we have to talk about the zero point 0.3 size particle because that settling per velocity is not equal to my SOR. So how much of them will be removed? So now the ratio will come into picture. So I will just show how you. So it says that I from first that the settling velocity of zero point 0.4 mm size particle or greater, it can be zero point 0.4 or greater, is equal to the surface overflow rate. So those solids will be removed 100%. Okay. So the weight is 60% of 500, that is 300 grams. So all 300 grams will be removed. Now what about 0.3 mm size particles? Here the settling velocity divided by the surface overflow rate. That by that ratio only it will be removed. Okay, so settling velocity was 0.25. The surface overflow rate is 0.3. So 0.25 by zero point 0.3 into 100 will give me the efficiency of 0.3 mm size particles simply. So it is 83.33%. So out of the total 100%, only 83.33% of my particles will get removed of 0.3 mm size. So we will find out that. So out of total 500, 40% is my zero point 0.3 size particles. Out of that, only 83% will get settled. So it is 166.67. Is it clear? So what is the mass of total volume that is removed from the system? So can now someone tell me the efficiency of the system? What is the efficiency of the system, overall system? We have found out the efficiency of zero point 0.4 mm particles. We have found for 0.3 mm particles. So now what is the overall efficiency of my system? Okay, the answer is already there. You just have to tell me how do we calculate it. The answer is already there, 93.33% it is. So all the 300 grams of zero point 0.4 mm particles and 167.67 gram of zero point 0.3 mm particles will get removed. So total removal will be 300 plus 166.67, that is 466.67 grams will get removed. Now what was my total solids? That was 500. So my efficiency will be 466.67 by 500. So that is 93.33%. Okay. Is it clear for all of you? Others, please respond. I think only two people are responding, others are not saying anything. Please let me know if you are just understanding or not. I will explain it again and again. No problem for me. Saket, others, I am asking about others, other than the two people who are responding every time. I can see few more names. I don't want to name them, but please give some reaction if you are understanding or not. Because these questions, though it may seem difficult, but these are from your previous assignments only. Okay, so these type of questions can very well come in the examination. There is no doubt about it. It's not a big problem. So these questions, the last question, these can very well come in your assignments or even in your exams. So please try to understand these problems here itself. If you have any query, please let me know. Okay, so we'll move forward. I think it is understandable to all of you. Okay, so this is the next problem. The aeration tank in a wastewater treatment plant contains a mixed liquor volatile suspended solids, or we call it as MLVSS, concentration of 3000 milligram per liter. The plant receives a primary effluent of biological oxygen demand of 208 milligram per liter and a flow rate of 12 mld, that is million liters per day. The aeration tank volume is 1875 cubic meters. We have to find the food to microorganism ratio, or we can say the F by M ratio. So the MLVSS is given, the influent BOD is given, the flow rate is given, and the volume is also given. So we have to calculate just the F by M ratio. So can anyone tell the answer? What will be my F by M ratio? So what are all the parameters that are required to calculate the F by M ratio? Can someone tell me? What are the parameters required to calculate the F by M ratio?
Flow rate,
Yes,
BOD,
yes,
volume, and MLVSS.
yes. So that's all. You have all the four values. Just calculate it.
Sir, 0.44.
0.44. You are getting it as 0.44. Okay. I don't remember the answer. I will check. I will check the answer. Yeah, it is 0.44. So it's absolutely correct. So what is the formula that we used? Can you tell? What is the formula?
Sir, flow rate into BOD upon
Yes.
uh, MLVSS into volume.
Okay. So Saket, can you tell me what is flow rate into BOD? What is that?
Sorry, sir.
What do you mean by the term flow rate into BOD? What is it actually representing in the
It is
system?
food. It is
It is
food.
the
Food.
food. It is the food because the biological oxygen demand will tell me how much of organic matter is coming into the system. So organic matter is milligram per liter into the flow rate. So how much mass per day or per time of food is coming to my system. So that is my food. Now, M is the microorganism. Microorganism we can find out from MLVSS because VSS or any volatile suspended solids will represent my biomass in the system. Okay, so again, VSS into my volume will give the microorganism. So F by M, or we can say food to microorganism ratio, directly we can calculate like this. So Q S naught by Vx. So Q is the influent discharge, S naught is the BOD or the food to the microorganism, V is the volume, and X is the MLVSS or the microorganisms present in the system. Okay, so directly we can find out like this. I hope it is clear to all of you. Fine. So we'll move to the next problem. Okay, it's a very easy one. Wastewater has various kind of nutrients present which can be used by microbes for cell synthesis. Select the nutrients which are categorized as major nutrients. So which among them are the major nutrients, or we can say the macronutrients? Is it sulfur, phosphorus, calcium, sodium, nitrogen? So which are the major nutrients? Anyone?
Calcium.
No, I don't think so. We are talking about the major nutrients. What are the major nutrients that we are dealing with in any wastewater system? Like for which we design our wastewater system generally.
Uh, ni- so nitrogen and phosphorus.
Nitrogen and phosphorus. Yes, Prashant is saying it's nitrogen. It is true. Nitrogen is one of the nutrient and also phosphorus. So both nitrogen and phosphorus, both B and E are right. Right. Others can be micronutrients. Okay. So those are also required for cell synthesis, but the major nutrients or the macronutrients are only nitrogen and phosphorus. So these can be easily found in our wastewater. So you might have seen, we have a nitrification, denitrification system. We have a phosphorus removal system in our wastewater treatment plants because these are the major nutrients. So human waste is basically the key source of these nutrients in the wastewater. All the feces that is going into the wastewater are the major contributors, or any runoff from the agricultural place and all can be also be rich in nutrients like this, nitrogen and phosphorus. Okay, so this is about the fifth question. The sixth question now. Which of the following is not a step in activated sludge process? So we have learned about activated sludge process. You have to tell me which is not a step of activated sludge process. So A is mixing and aeration of mixed liquid. B is settling of mixed liquor to separate the sludge. C is anoxic condition for denitrification. D is drying of sludge, and E is flocculation of mixed liquor. So to tell me which of the following is not a step in activated sludge process. D. Okay, Prashant is telling D. Others would like to give it a try.
It's a drying of sludge.
Drying of cells. So it is pretty direct. Other things are actually very much important steps of the ASP. So drying of sludge is not a main is not a step in activated sludge process, though drying of sludge can be done later for sludge management to be used later as a compost or anything. So that time drying can be used, but in activated sludge process or my biological treatment, the drying of sludge is not a part of that. Okay, so this is the brief schematic of the activated sludge process. So here you can see first the influent is coming in the aeration tank. So mixing and aeration is a part of ASP. Then settling of mixed liquor, which is done in the clarifier where the settling of the biomass happens, and then anoxic conditions for denitrification. So as I just in the last question we came to know that nitrogen is one of the important nutrients. So that has to be removed from the system. So denitrification is done. So anoxic condition for denitrification is another step for ASP. Then flocculation of mixed liquor. Flocculation of mixed liquor happens in the secondary clarifier where the biomass will agglomerate with each other and it will settle down. Okay, so all the four are the part of ASP. I hope it is clear to all of you. We will move to the next problem. Okay, the composition of total Geldal nitrogen in domestic sewage is expressed in milligram per liter as nitrogen, which is the result of the addition of. So we have to tell me what the TKN value consists of. Okay, total Geldal nitrogen we commonly say. So is it nitrogen from organic and inorganic sources, or is it organic and nitrite, or is it organic and ammonia, or is it ammonia and nitrite? So which of the following combination is a part of a total Geldal nitrogen?
C.
C. Okay. Anyone else would like to try? Prashant, Saket, or Archana? Which of the following can be the part of the TKN value?
Organic nitrogen and ammonia.
Ammonia. So, as you both have rightly pointed out, so organic nitrogen and ammonia. So both are the part of the TKN value. Okay. So so can someone tell me like how what are the other forms of nitrogen present in the sewage? What are the other forms? One is organic source, one is ammonia. What are the other forms? What other forms of yeah,
Inorganic like nitrites and nitrates.
nitrites and nitrates, yeah. So both. So once ammonia is present in the system, and if the system is having enough oxygen and all a microorganism, then it can be oxidized to nitrite first, and then the nitrite can be oxidized to nitrate. So nitrite, nitrate in that form also it can be present. But when a freshly sewage is mixed with water, generally only the organic nitrogen and ammonia is present. As long as now slowly once it starts oxidizing, we can see the traces of nitrite and nitrates. Okay, so these are the different forms of nitrogen in the sewage. Okay, so again one more problem is there. So it is telling that consider a completely mixed activated sludge process, again from ASP. So the parameters are given: flow, the influent BOD, the HRT, the biomass concentration, the quantity of sewage sludge also, then the Y, KD, average time for biomass, the SRT value. Now assume that the authorities enforce a treated wastewater standard of BOD is equal to 20 milligram per liter and suspended solids of 20 milligram per liter. The MLSS concentration required in the system is. So we have to find out the MLSS concentration or the X value which we generally find out. So what would be the answer? So we have all the parameters that is required. So please try to solve this problem. It's a direct equation related problem. All the parameters are given in this. Just it's the matter of applying that formula and putting the right values with the correct units. You get the answer.
So 3 days is MCRT value.
SRT, sludge retention. Yeah, you can say MCRT, SRT, BSRT. Okay, shall I discuss the solution? We'll see how to just directly apply the formula. So the answer is 1982.6 milligram per liter, and the formula which we are going to use is this: X is equal to Y S naught minus S theta C divided by 1 plus KD theta C into theta. Okay, so once we apply all this, we will directly get the answer. So it will be X is equal to 1.1982.6. Okay. Is there any confusion? I think there is one extra equal to sign in the second line in the solution. That should be plus. That is 1 plus 0.05 into 3. Okay, so that is not equal to, that is 1 plus. I will rectify in the PowerPoint later. So by this equation, we can directly find the solution.
Sir, HRT will be in days or hours?
HRT will be in hours. So uh, that's why it is given in hours. But for this question, we have to convert into days because everything else is in days. So that's why 0.125 that term is coming.
Okay, sir.
0.125 is the theta. So HRT generally is in hours, but for the question, we have to convert it in days. Is it clear? So we'll move to the next problem. Again, I think one more problem is there. Yeah,
How 0.125? How is it 0.125?
it is 3 by 24, right? So
Okay. Okay.
yeah, 3 by 24 it is. So 0.24. Okay, so I'm moving to the next problem. So it is saying that consider a wastewater plant which is set up in Shimla. So the elevation of the city, the annual average design temperature, the standard oxygen transfer rate, the alpha, beta, F value is also given. The concentration at 20 degrees Celsius, the concentration at standard temperature, everything is given. The PD, ATM value are also given in the question. So we have to find out the average oxygen rate, oxygen transfer rate. So standard oxygen transfer rate is given. We have to find out the average oxygen transfer rate in the aeration tank because we know that the amount of oxygen that can be dissolved or that can be transferred into the system will vary with respect to temperature, elevation. Okay, so all these factors have to be taken into account, and then the actual oxygen transfer rate have to be found out. So since this wastewater plant is being set up in Shimla, so my elevation will change, my temperature will change, all the parameters will change. Okay, and where my air release is happening, whether it is at full depth or whether at what location. So all those things, all those factors you have to take into consideration and then find out the answer. So it's basically a direct formula one, though the formula looks complex, but uh, that is how we have to find out the solution for this. So just know the reasoning behind it because standard oxygen transfer rate is generally given by the manufacturer, like for that particular aerator or that particular diffuser, the standard oxygen transfer rate will be given. Now, if you are setting up that diffuser at some other places where the temperature and elevation is different, my oxygen transfer rate will change. So to calculate the changed or the average oxygen transfer rate in that location, we have to make all these corrections. I'm just telling you the reasoning behind it, but the procedure remains the same. We have to just use two formulas and then we have to find out. So I think the formula is little complex. I will directly show you the formula. So the correct answer is 21.16 kg of O2 per hour. So first we have to calculate the C average. Okay, the average concentration. So for that we have the equation as the standard concentration into 0.5 into PD by PD ATM, where PD is the pressure at all depths, at full depth of air release, and PD ATM is the pressure at water surface, that is the atmospheric pressure. So at full depth and at atmospheric pressure, what is my pressure? And OT is the oxygen transfer in the air leaving water. So this is the oxygen in air present. So divide by 21 because 21% is present in air, oxygen. So if you do all this calculation, we will get the average value of concentration. And then AOTE, that is the average oxygen transfer rate, can be found out by SOTE into beta CS minus CL into alpha F 1.04024 T minus 20 by CS20. So this is the equation that we have to memorize, and then just it's a simply we have to put in the values and get the answer of the average transfer rate. Okay, is it clear? Like, I hope you are able to understand what is the logic of finding these values, because my elevation and temperature will change with the different place. So that's why we are trying to find out. So though the standard oxygen rate is given as 36.5 kg of O2 per hour, but at Shimla, with all those conditions, we are able to get only 21.16. So around two-third is only what we are getting. Even less than two-third we are getting. Okay. So I hope it is clear to all of you. Okay, we'll move to the next problem now. So it says that which of the following factors affect the efficiency of coagulation-based sedimentation in wastewater treatment? So if we are doing coagulation-based sedimentation, so what are the factors that are applicable? So first is the pH, then the temperature, the surface overflow rate, and all of the above. Please tell me the answer. D, all of the above. Okay, yeah, it's a pretty direct.
So
So
all of the above.
all of the. So can someone give me an example like how pH will affect the coagulation-based system? Like where you might have seen the pH is governing the uh, coagulation. Can you give any example? Okay, so coagulation will be higher in case of higher surface overflow rate or lower surface overflow rate. Which will help in coagulation? High surface overflow rate or low surface overflow rate? Just think logically and try to answer. Okay, so I will discuss. So D is the correct answer. So we can see that pH is an important like factor, because at certain chemicals will only precipitate or coagulate under certain pH range only, because based on their ionic formation, like we have aluminum coagulants which will the optimum pH range is 5 to 6.5. For ferric coagulants it is around 4.5 to 6. So based on pH and based on their ionic formations only they will be able to settle or coagulate. Then low temperature can slow down the coagulation process. Okay. And also increasing the SOR will reduce my coagulation efficiency. So at high SOR, if the surface overflow rate is high, then my coagulation efficiency can decrease. So all these factors will govern my coagulation. Fine. So this was all about 10th question. So the next question is, during sedimentation treatment of wastewater, the influent from primary clarifiers enters the aeration tank, secondary clarifier, disinfection tank, none of the above. So direct question which you have discussed. Yes,
Aeration tank.
aeration tank. So I think no need to spend more time in this. So it is directly aeration tank. So influent of the second of the primary clarifier will move to the aeration tank and then to the secondary clarifier and then to the disinfection if required. Okay. A probable electron acceptor in anaerobic or anoxic respiration is, which of the following is a electron acceptor? Organic matter, nitrate, sulfate, all of the above.
Nitrate.
Nitrate. Okay, someone is telling organic matter. What else? There is a confusion between the two. So can
So,
someone else?
so organic matter.
Organic matter. Okay. Okay. So what about sulfate? Is it not an electron acceptor? So sulfate is also an electron acceptor, right? So even actually all the three are electron acceptors in anaerobic or anoxic respiration. So organic matter, nitrate, sulfate, everyone can be an electron acceptor.
But organic matter is a electron donor,
It can
isn't
act
it?
as an electron acceptor also. So at various time places, it can act as an electron acceptor as well as electron donor. Okay. So we can say that oxygen is basically an electron acceptor in aerobic process. Organic matter is an electron acceptor in anaerobic process, and sulfate and nitrate are electron acceptors in anoxic process. So in this question, we are asking about anaerobic and anoxic. So both organic matter, nitrate and sulfate will act as electron acceptors. And also organic matter can act as electron donor also in a few cases. Okay, so it can act in both the ways.
Sir, what is the concept of facultative bacteria?
Facultative bacteria are different. Facultative bacteria are those bacteria which are able to survive in the presence of oxygen or in the absence of oxygen also, or minimum oxygen also. Okay, so there are basically broadly three types of bacteria. One is aerobic bacteria, which needs oxygen to survive, and there are strictly aerobic, which needs only oxygen to survive. If there is a little bit of anoxic condition, they will, or anaerobic condition, they will die. Then we have the anaerobes, which doesn't need oxygen to survive. And there are strictly anaerobes, which need no oxygen to survive. If there is any oxygen, they will die. And then in between, there are facultative bacteria, which can survive in both in the presence of oxygen or in the absence of oxygen. Okay, so it's based on their respiration, like how they are able to survive under what condition. Okay, okay, sir. Okay, so we'll move to the next problem. The advantages of biological treatment processes over physicochemical processes are cost effectiveness, lower energy requirements, both A and B, less time consuming. So, which of the following are the advantage of biological over physicochemical?
Less time consuming.
No, I'm talking about advantages of biological treatment. C. Yes, I think so. Prashant is telling the right option because biological treatment are basically dealing with microbes. So the activity of microbes and all will take some time. It will take time to acclimatize. It will take time to decompose all the organic matter and all. So it is very time consuming. So it is a disadvantage of biological treatment.
You have
Whereas
to flush oxygen, but you have to flush oxygen. That is a costly affair.
no, flushing. No, if we are suppose we are going for anaerobic treatment, like the upflow anaerobic sludge blanket, there no oxygen is required. Okay,
Biological treatment, microbes need oxygen to
no, not
oxidize
really.
the.
No, no, no. If it is an aerobic process, like activated sludge process is an aerobic process, so we need oxygen to require. But suppose we are going for anaerobic digestion, we are going for upflow anaerobic sludge blanket reactor, or in any type of systems where anaerobic bacteria are required. They don't need a single amount of oxygen. Okay, so they
But
don't
still,
need.
I have a confusion. When we are talking about biological treatment, it means
No, we are
treatment done by the microbes only.
Yeah, microbes only, but there are different kinds
But
of
microbes
microbes.
means, but it is nowhere mentioned anaerobic in the
No, but
question.
so if we say in general, if we say the amount of energy required for physicochemical and biological, even if we are giving them aeration, okay, so aeration will require some amount of energy, but in physicochemical also we need maybe to stir the tank, we have to provide diffusers or something, so that will also contribute to more energy. So overall, if you see in general, the biological treatment with aerobic and anaerobic treatments, it requires lesser energy than the physicochemical processes. Because in physical chemical processes, maybe we have to heat the sample, we have to change the temperature. Okay, so all these physical things we have to supply chemicals, so it is not cost effective at all. So chemicals are very costly. We have to give more pumps and all those recirculators. So all these things will add up to your energy and cost. Okay, so, but whereas in the case of biological, as a whole, in general, they take lesser energy in with respect to physicochemical. Because a major portion of our biological treatment comes from anaerobic treatment. All the sludge management, all the anaerobic treatment and all are requires only requires no oxygen at all. Okay, so if you see in general as a whole, the biological treatment are less energy intensive than the physical chemical. Okay, though it is not mentioned explicitly here, but in as a whole, they require lesser energy only.
Okay.
Okay. So this is what it is regarding the biological treatment and the physical chemical treatments. Okay, so we'll move to the next problem. When organic material is used as an energy source, it is converted into stable end products by the process of. So the conversion of organic material into stable end products. Suppose we have organic material and with the help of microbes and oxygen, we are converted into carbon dioxide and H2O, stable end product. So what is this process called? Is it anabolism, catabolism, catalysis, pyrolysis?
Catabolism.
Catabolism. So it is very direct. It is called catabolism. And what is anabolism? Can someone tell me?
That is making up of cells, I suppose.
Yeah, it is synthesis of new cells. So that is anabolism. Catalysis is the use of catalyst, and pyrolysis is another sludging of waste management procedure where in the absence of oxygen we degrade the matter. So that is that those two are different. Uh, it is basically a physical chemical process, pyrolysis. Okay, so this is all about catabolism. Now, the next question, it says endogenous respiration is a process of. So here we are talking about endogenous respiration. So is it derivation of energy required for cell synthesis exclusively through oxidation of organic matter by microorganisms, or is it through the oxidation of own protoplasm by the microorganism, or is it for synthesis from inorganic substances or from photosynthesis, or is it all of the above? So here we are talking
All of
about
the above. All of the
no,
above.
actually we are talking here about endogenous respiration. Okay, so in endogenous respiration, what happens? So can someone tell me like what are the various phases of a bacterial growth? There are four phases actually. So what are the four phases of a bacterial growth? Suppose this is my amount of microbes present. Okay, amount of microbes present, and this is time. So you might have seen this curve. Okay, so this first stage, this stage is known as lag phase. Now this stage where there is a like an increasing line, this is the log phase. Then this is where we have a flat line. This is the stationary phase. And when it starts decreasing, this is the endogenous phase. So I am talking about endogenous phase of bacterial growth. So in this phase, what happens? The energy is derived by the oxidation of the own protoplasm of microorganisms. Okay, so they feed onto themselves or the other bacteria.
Is it same as the death phase?
Yes, like in the death of the microorganism start from the stationary phase only, but in the stationary phase, the uh, amount of microorganism that is produced is equal to the death phase, is equal to the death. So there both is same. Whereas in the endogenous phase, they slowly go into the death death phase. So they feed onto each other, or there is oxidation of their own protoplasm. So this is the endogenous respiration. Okay,
Okay.
fine. So this happens when all the food supply to my system is over. If my food or some organic matter is present, then the energy will be attained from the oxidation of organic matter. Okay, or is the if there are some inorganic sources or if photosynthesis is possible, then energy will be required from this. Whereas in the case of endogenous respiration, there is oxidation of its own protoplasm of by the microorganisms. Okay, so endogenous phase, the correct option is B. So we can say in the absence of any suitable external substrate or organic matter, the microorganism derives its energy through the oxidation of its own protoplasm. Such a process is known as the endogenous respiration or death phase or the decay of the microorganisms. Fine. Okay, so the next problem now. Identify the most appropriate choices for statement A and B. So we have two statements. The first statement says the nutrient requirement is lower in anaerobic processes than in aerobic processes. Second, the growth rate of microorganisms is lower in anaerobic processes. Okay, so we have to tell whether both statements are true. We have to say whether uh, are you able to hear me? I think there was a network problem.
Yes, yes.
Ah. So the question says, are both statements are true? Both are false. A is true, B is false, or A is false, B is true. Please go through the statements again and let me know the correct option. So here we are comparing anaerobic and aerobic processes about their growth rate and their nutrient requirement. Anyone with an answer? So just to help you, we should know that in any anaerobic processes, the amount of energy derived per unit of the organic matter is much more higher than the anaerobic processes. So for comparison, you can say that around 36 ATPs are generated per molecule of glucose in aerobic systems, whereas only 2 moles of ATPs are generated per mole of glucose in anaerobic. So the amount of energy derived from aerobic processes is very high as compared to anaerobic processes. So now can you tell me, if the amount of energy derived is very high for anaerobic processes, what will be my growth rate of microorganisms? Will it be more or less than the aerobic processes? So it should be definitely very high. Okay, so if more energy is generated by the degradation of organic matter, so more and more microorganisms will grow in the aerobic processes. So statement B is true. It says that the growth rate of microorganisms is lower in anaerobic process. So in anaerobic process, the growth rate is low because less energy is derived. Now, if growth rate is low, then the nutrient requirement will also be less. Fine. Okay. So statement A is also true. Like as compared to aerobic processes, the anaerobic process will have lower growth rate and lower requirement of the nutrients. So both the statements are true, hence option A is correct. Okay, so nutrients are required for synthesis of new biomass. However, the generated ATP is the energy unit, adenosine triphosphate, is low in anaerobic process. Therefore, the nutrients required is low due to low growth rate. Is it clear to all of you?
Yes.
Okay, so option A is correct. Next, the sludge volume index or the SVI of the wastewater refers to duration of solid retention in aeration tank, total organic content in secondary sludge, sludge volume produced due to secondary treatment, or settling characteristic of sludge in aeration tank. So what does SVI or the sludge volume index represent in a wastewater sludge?
It's D.
It's sorry,
D.
D. Okay, yes. So sludge volume index always represents the settling characteristics, like the amount or the volume of sludge settled per unit mass. Okay, so it gives the settling characteristics of the sludge. So option B is correct. SVI is the volume in ml occupied by 1 gram of activated sludge after settling the aerated liquor for 30 minutes. Therefore, it indicates the settling characteristics of the sludge in an aeration tank. So the volume per unit mass is the SVI. Okay. Next question. Identify the correct statement regarding the activated sludge process. So we have two types of activated sludge process. One is the extended aeration and one is the conventional ASP. So extended aeration is we are aerating the system for very long time, to such a long time that all my food will get over definitely by this time. So one is the extended aeration and one is the conventional ASP. So we have to tell me for which of the following the statement is correct. F by M ratio of extended aeration is higher than conventional ASP. F by M ratio of extended ASP is lower than conventional ASP. HRT of extended aeration is lower than conventional ASP. SRT of ASP, conventional ASP is greater than extended aeration. So which of the following statement is correct? Here the name suggests it's extended aeration. So some things should be high and some things will become low with time. So we have to find out the correct statement.
by M ratio is lower.
Is lower. So definitely, as you rightly pointed out, the F by M ratio will be lower because with extended aeration, all my food will get utilized. So it can run at a very small F by M ratio. Okay, and HRT will be high because it's extended aeration, and also SRT will also be high for extended aeration. So that means option B is correct. So that's what I've written in the detailed solution also, that F by N ratio is lower in the case of extended aeration system, whereas the HRT is high in extended aeration and also the SRT is high in extended aeration. Okay. Now next question. The degradation of organic matter in biological treatment processes is typically due to, is it due to photoautotrophs, photoheterotrophs, chemoautotrophs, chemoheterotrophs? Photoheterotrophs. So
Chemo,
can
chemo,
someone tell me what do you mean by photo?
sunlight.
Light.
Light. Light, it means the microorganisms are deriving energy from sunlight. Whereas in the biological treatment process, photo degradation may not be the case always. Whereas chemo means chemically derived energy, maybe from the chemical processes of degradation of the organic matter. So chemo is the correct give you the correct picture of organic matter degradation, okay, rather than photo. And what do you mean by autotrophs? Like which organisms are called autotrophs?
They depend upon others for food.
Is it
They
others
can't
for
make their
food?
own food.
Yeah, I'm talking about
But
autotrophs. Auto means
heterotroph,
for self. Self. Auto means
yeah,
self.
or yes,
Yeah, so autotrophs basically depend on inorganic sources like carbon dioxide and other things for their energy. Okay, but heterotrophs will depend on the organic matter. So the degradation of organic matter in biological treatment process is typically due to chemoheterotrophs. Okay, chemoheterotrophs. Chemo means chemically derived. Hetero means the heterogeneous or the organic matter. Okay, so that depend on the organic matter. Okay, the next question. The rate of microbial growth and metabolism depends on food to microorganism ratio, sludge solid retention time, sludge volume index, none of the above. So pretty direct question. The rate of microbial growth and metabolism will depend on F by M, SRT, SVI, or none of the above.
food to microorganism ratio.
So food to micro, it is very direct, like how much food is available and what is my concentration of microorganisms. Based on that, the rate of the microbes will depend. Okay, whereas the solid retention time and sludge volume are the not right option. Your sludge volume index will give the settling characteristic of my sludge. So food to microorganism ratio is the correct answer. Okay. So again a question on SVI. It says 1 liter of sewage sample when allowed to settle for 30 minutes produces a sludge volume of 27 centimeter cube. The dry weight of its sludge is found to be 3 grams. The sludge volume index is 9, 24, 30, 81. Pretty direct question, very directly we can find out the answer. So please tell me.
9.
9. So directly we can find, just divide the volume by the amount of sludge in mass. So volume occupied in ml by 1 gram of solids. So 27 by 3, it is 9. Very simple question, directly we can find. Okay, so the next question is, so next 4 questions are dependent on this data. So you can take a screenshot of this question because again and again the same data will come up. So it says that an activated sludge process with a tank volume of 8,000 meter cube receives an inflow of 5 mld sewage with a BOD concentration of 300 milligram per liter. So we have V, Q, and we have the BOD, S. The steady state BOD concentration in the aeration tank is 30 milligram per liter, and the MLSS concentration X is measured as 500 milligram per liter. The concentration of biomass in the recycled sludge is 20,000 milligram per liter, and the recycled flow is 50 meter cube per day. Now neglect the biomass concentration in the effluent, that is Xc is neglected. So this is the data. The question is not yet asked still. So this is the data. So I will just write down all the parameters what we have. So we have V is equal to 8,000, Q is equal to 5 mld, S is equal to 300 milligram per liter, and then S not SE that is coming out is 30 milligram per liter, X is 5,000 milligram per liter, XR value is 20,000 milligram per liter, QR is 500 meter cube per day, and XC is 0. Okay, so we'll see I hope we have noted down this problem. We'll see the first question. So the first question says again the F by M ratio. So please calculate and tell me what will be my F by M ratio. We have already solved this problem. Please tell me. I think there is no need to discuss it again.
So please saw the question.
Okay, this is the question. So we have to calculate the F by M ratio. So as you have pointed out correctly last time, it is QS naught by Vx. QS naught by Vx.
Point 0.0375.
So 0.0375 directly if we have found out QS naught by Vx, we can get the answer. Okay, now next question. The volumetric loading rate in the aeration tank is, what is the volumetric loading rate? So just try to recall the equation for volumetric loading rate. What is that? It is almost similar to F by M ratio, just one term will be missing from that. So volumetric loading rate is nothing but Qs naught by V. So Qs naught by V will be my volumetric loading rate. Okay, is it clear? Qs naught by V. So it is 187.5 gram per meter cube per day. I hope it's very easy. I will go to the next problem. The sludge retention time or the mean cell residence time.
187.5.
Oh, okay, you calculated the last. Yeah, it is correct. 187.5. 187.5. Now calculate the sludge retention time or the mean cell residence time. I'll wait for a minute. You will see how to solve this problem. The correct answer is 4 days. So SRT is equal to V into X by QR into XR plus QE into XC. Okay. So it basically says the amount of mixed liquor that is present in the aeration tank divided by the uh, liquor, the TSS wasted per day plus the TSS lost in the effluent. So here we know that Xc value is 0. So the last term will be 0. So it will be directly Vx by Qr into Xr. So if we put on the values Vx, Qr, Xr, we will get the answer as 4 days. So Vx by Qr into Xr because Xc is 0 in this case. But if Xc value is given, then we have to incorporate it. Directly we can find out the answer. Okay, the next problem. The BOD of the final effluent will be. So for this, no calculation is required. Can you tell me what will be the BOD of the final effluent? No calculation is required from it. You can directly tell. So what was my BOD in the aeration tank given in the question? Has anyone noted it down? So the BOD in my aeration tank was 30 milligram per liter. So what will be the BOD of my effluent?
It is 30 milligram per liter.
It will be 30 milligram per liter because whatever we have achieved in the aeration tank will be the same. Okay, there is no removal considered in the secondary settling stage. So it will be same as my effluent from the aeration tank. Okay. Okay, so next problem, it is a descriptive one. So here it says an aeration basin receives 3,800 meter cube per day of primary settled wastewater. The influent and effluent soluble BOD are 160 and 6 milligram per liter respectively. The process data include y is equal to 0.5, kd is equal to 0.06 per day, MCRT or theta c is 10 days, BOD 5 by BOD ultimate is 0.68. We have to calculate the biomass growth and the oxygen utilization. So please note down the problem. I will solve it in my notepad. Then we can check. Okay. So this is the problem. We have to find out the biomass growth and the oxygen utilization. So I will solve this problem now. So in the question it is given that Q is equal to 3800 meter cube per day. The BOD in S0 is equal to 150 milligram per liter. S effluent is 6 milligram per liter. Y is 0.5. KD is 0.06 per day. Theta C is 10 day. And the BOD 5 and the BOD value is F, that is 0.68. Okay, so all this data is given. So first we will, for biomass growth, we need the Y observed value because the Y total value is given. So we have to find out the Y observed value. Y observed value is Y minus 1 plus KD theta C. So it takes into consideration the decay rate also. So what is this? 0.5 divided by 1.1 plus 1 0.06 into 10. So my Y observed value is 0.31 gram of VSS per gram of BOD5. So this is my Y observed. Now once Y observed is we are found out, so we can calculate the biomass growth. So what will be my biomass growth? It is written as Px. So it will be Y observed into Q into S naught minus SC. So Y observed is 0.31 into 3800 into 150 minus 6. Okay, so it will be, I will convert into kg, so into 10 to the power minus 3 I will do. So it is 170 kg VSS per day. So this much of biomass will be produced based on the given data. Now my oxygen utilization, because now more microorganisms means my oxygen requirement will be lesser for utilization. So it will be O2 utilization rate. It will be equal to Q S naught minus S. So this is the total oxygen required divided by F because of the factor of ultimate BOD minus 1.42 because 1.42 times biomass will require oxygen. So we have to supply this oxygen.
What is F?
F is the ratio of BOD5 by BOD ultimate because we are calculating everything in terms of BOD5, but for oxygen utilization we have to convert into BOD ultimate, like the total BOD present. So we have to divide by F. So it is 3800 into 150, sorry, 150 minus 6. I will convert into kg, so 10 to the power minus 3 divided by 0.68 minus 1.42 into 170. 170 is already in kg. So we get answer as 805 minus 241. So it is 564 kg O2 per day. So this is my oxygen utilization rate. Okay, a pretty direct question. Okay, so I hope it is clear. So first we calculated the Y observed value based on our YT value. Then we calculated how much biomass is growing. So we subtracted it from the total oxygen required. So oxygen utilization rate. Fine. So these are the answers. Okay, so we will stop here today. If you have any queries, you can ask me regarding today's class. Anything else to be discussed again, or any other type of question you want to solve, please let me know. Or if you want me to derive the equations for ASP, I can also do that if you want. Okay, so the next class will be on 23rd of February, again in the same time, 7 to 9 p.m. on Friday. And this is my contact information is also given, so you can get back to me with any query on this mail. Okay.
Could you please next time solve some question in which there is return sludge?
Return sludge. Okay,
Yeah.
I can solve. So you want me to directly solve the question, or you want me to derive it? Like I hope you are familiar with the equations. Then we can directly solve the
But
problem.
how to use it? How to use it? That's it.
How to use it? Okay, I have a question. I think. Mm, Okay, so this is one question. I will just quickly go through it. Like a completely mixed activated sludge process is to be used to treat a wastewater flow of 5 mld having BODU of 300 milligram per liter, and then the design criteria is given: X 2000, Fe is effluent, BOD is 10, R is 30 to 40%. Okay, 30 to 40% of my wastewater flow. YT is 0.5, K value, KD value, MLSS by MLVSS, SVI, everything is given. So you have to calculate the aeration tank volume, the operating BSRT, and the hydraulic retention time. So basically for the hydraulic retention time, we need the R value, the recycle value. So just take a screenshot of this problem. I will solve how to do this. So we have to find out aeration tank volume, the BSRT, and then the hydraulic retention time. Okay. So question. So here for calculating the first the tank volume, we have to first calculate the tank volume. So for that, we need to use the specific substrate utilization rate, Q. So Q is basically is equal to K into SC. So the K value is given as 0.1 into 10. 0.1 and SC is 10. So it will become as 1 per day. This is the value of Q. Now we know this equation. Q is equal to capital Q S naught minus SC by X into volume. So from here we will get the tank volume, right? So my V equal to Q S naught minus SC by X into small q. So if we substitute all the values, we will get the tank volume as 725 meter cube. Okay. So now once we get the tank volume, we will find the BSRT, the sludge retention time. Okay, so for this the equation is direct: 1 by theta c, theta c is the BSRT, is equal to YT into KSC minus KD. So we will simply substitute the value: 0.5 into 0.1 into 10 minus KD, KD is 0.1, so my theta c will turn out to be 2.5 days. So now once we have got this V value and once we know the theta C value, we can now go for the sludge recycling ratio. So now we will find out the recycling ratio R. Okay. So for that we have to find first the XR, the recycled biomass. So that is equal to 10 to the power 6 by SVI. So 10 to the power 6 and SVI is 100. So it is 24 milligram liter as MLSS. Okay, as MLSS. This will be as MLSS. Now, to find the recycle ratio R, we have to use this formula. 1 by theta C is equal to Q by V, 1 plus R minus R XR by X. So from here we can, in this equation, we have found out all the theta c, q, v, xr and x. So we can get the r value. So if we substitute, 1 by 2.5 is equal to 5000 by 725, 1 plus r we don't know into r into now xr we know as 10 to the power 4 milligram per liter as MLSS, but in terms of MLVSS it will be zero point 0.8 into 10 to the power 4 because MLSS by MLVSS ratio is also given in the question, 0.8. So 0.8 divided by 2000, 2000 is my x. So my R value will turn out to be 0.2355 or 23.55%. Now once we get the R value, we will calculate the HRT. So how to calculate the HRT? HRT theta is equal to V by Q into 1 plus R. If there was no recycling, that 1 plus R term will not be there, but because of recycling, that 1 plus R term is coming. So it will be 725 divided by 500 into 1 plus 0.2355. So we will get theta as 0.12 days, or we can write it as 2.82 hours. So this was one example regarding the sludge recycling ratio. Is it okay?
Yes, thank you.
Okay. Okay, so we can stop the class here today. If you have any queries, you can get back to me over the mail. Okay.
Thank you so much.
Okay, thank you so much. You can leave the session. Archana, if you have any queries, you can ask me or you can leave the session.